Okay, so for example 3, find the volume of the solid formed by rotating the region in the first quadrant bounded by the graph of y equals square root of 16 minus x squared about the y-axis. So we're rotating it this time around the y-axis instead. So this is going to change some things. Because we have to draw our slices, or in this case our discs, perpendicular to our axis of rotation, these slices are going to have to be horizontal. So you know where we're going with this. Okay. So this means we're thinking in terms of y when I'm thinking of this slice here. We know that the height of this disc created when we rotate it is simply dy. What we have to figure out is how to express this radius. So let's take a look at that. So when we're moving with a horizontal slice here, we're doing rightmost minus leftmost. So in this case, our rightmost is this curve function here. However, it's currently in terms of x, and I need it to be in terms of y. So let's do a little algebra here. If y equals square root of 16 minus x squared, we would first square both sides to get rid of the square root. And then you have a couple options here. I'm going to add x squared over with y squared. And then I'm trying to solve for x here to get it in terms of y. So I'm going to subtract y squared. And then I'm going to square root. Now when we square root, we really get a plus or minus. However, this is in quadrant 1, so we can kind of ignore the negative result of this and simply express it as the square root of 16 minus y squared. Okay, so I'm going to be thinking of that instead as x equals the square root of 16 minus y squared. Same function, just writing it in terms of y. So that means when we set this up here, we're going to do right minus left, where right we just rewrote as square root 16 minus y squared, and left is simply where x is 0, so that's just minus 0. Alright, we've got our lovely volume formula. That is the one thing that's very consistent in these disc method problems. And so for the volume of our slice, we have pi. Our radius, we can just write simply as square root 16 minus y squared. And then that's being squared. And then the height of our little disc is simply dy. So then when we find the volume of the solid, this is where we need to be careful with what we're integrating between. We know it's of the same expression, which of course you can simplify these if you really would like to. I just don't take the time to do it if I'm going to type it in my calculator anyways. But obviously if you square root, it's really just that inside function. So if you want to do that instead, that's fine. Our bounds, so we're integrating with horizontal slices. So you're telling me what's the lowest y value it reaches and what's the highest. So in this case, we're going to be going from 0 to 4. And those points always lie along that axis of revolution. So that's kind of a helping reminder that you should be looking at these numbers if you're revolving around that particular axis. So 0 to 4. And we're going to use a calculator on this one just to speed it up. And you should get the estimate of 134.041.